Okay, let's dive into this. We're going to explore one of the biggest questions there is. What is the human mind? And, with AI getting smarter literally every day, could a machine ever really have one? This is where the philosopher John Searle comes in. His work is, more relevant now than ever, and it totally challenges some of our biggest assumptions. So let's start with a really big question, a puzzle that sits at the very heart of our own existence. Think about it. Are you just a machine? We feel like we're conscious, thinking beings, right? But what if, deep down, we're just incredibly complex biological machines? And if that's the case, what on earth does that mean for AI? And this right here is the fundamental conflict that Searle really zeroes in on. On one hand, you've got our common sense view of ourselves. We're conscious, we're free, we have thoughts and feelings and all that good stuff. But on the other hand, you have this scientific view, and it tells us that the world is made up of nothing but mindless, meaningless physical particles. So, how do you square that circle? How can both of these things possibly be true? And to make this whole thing even trickier, the mind has these four features that are just so puzzling and really hard to explain with physics alone. First, you've got consciousness, that basic feeling of being alive. Then there's intentionality, which is a fancy word for how our thoughts can be about things. Like, you can think about Paris. How does that work? Third is subjectivity. Your experience is yours and yours alone. I can't feel your toothache, right? And finally, mental causation. How can a thought, something that feels totally non-physical, actually cause a physical action, like you deciding to raise your hand? Okay, so faced with this big puzzle, a really popular answer has popped up, especially in the tech world. It's this theory of strong artificial intelligence, or strong AI. And it's basically this idea, this myth, that the mind isn't all that mysterious. Nope, it's just software. The core idea of strong AI is pretty simple, really. It says the brain is just a digital computer, the hardware, or as Searle calls it, the wetware. And the mind? Well, that's just the computer program running on it. Think about it. This means consciousness is just software. And if that's true, you could theoretically run that same mind program on any kind of hardware, a supercomputer, maybe even a network of beer cans if you set it up right, and boom, it would become conscious. But is that really true? Could consciousness just be a program? Searle was, let's say, highly skeptical. So to really put this idea to the test, he designed a totally brilliant thought experiment. It's called the Chinese room. Okay, so picture this. You are locked in a room. Super important, you do not understand a single word of Chinese. Not a thing. In the room with you are some baskets full of Chinese symbols. You've also got a rule book, but it's in English. Now, this rule book doesn't teach you Chinese. It just gives you rules for manipulating the symbols based on their shapes. If you see this squiggle, go find that other squiggle and pass it out of the slot. So people outside start sliding Chinese questions under the door. You look at the shapes, you follow your rule book, and you pass back the corresponding symbols. And what do you know? Your answers are perfect. So perfect, in fact, that everyone outside is completely convinced they're talking to a native Chinese speaker. Okay, so you've fooled everyone. You're acing this test. But here's the absolute key question. Do you, sitting inside that room, do you understand Chinese? The answer is, of course not a single word. You're just pushing symbols around based on a set of rules. You have zero comprehension. And this, right here, is the genius of the thought experiment. It exposes a huge flaw in the whole strong AI idea. See, what the Chinese room shows is the critical difference between two things. What you're doing in the room, what a computer does, is called syntax. You're just following formal rules for manipulating symbols. It's all about the structure, the grammar. But what you don't have is semantics. That's the actual meaning or interpretation of those symbols. A real mind doesn't just shuffle squiggles around, it knows what they mean. And that's the whole point. A computer program is only syntax. It's just a set of instructions. It has rules, but it has no meaning. And Searle's argument is that no matter how complicated you make that program, you can't magically get meaning from just manipulating symbols. Syntax alone is never going to give you semantics. It's a dead end. So if the mind isn't software, then what is it? If strong AI is a myth, where do we go from here? Well, Searle says the answer is actually pretty straightforward. It's not about computers or code. The answer is biology. Okay, so here's part one of Searle's claim. He says that mental phenomena, your thoughts, your feelings, everything that happens in your mind, are caused by processes going on in your brain. Pretty simple, right? We're talking about things like neurons firing, neurotransmitters zipping across synapses, all that biological stuff. But then comes part two, and this is where it gets a little trickier. He also says that these same mental phenomena just are features of the brain. Now, wait a second. How can something be caused by the brain and also be a feature of the brain? It sounds kind of like a contradiction, right? Like the brain is causing itself?
Well, to wrap our heads around this, we need a little help from physics. There's this idea of micro and macro properties. Basically, it's a way of explaining how a whole system can have properties that none of its individual tiny parts have on their own.
The best analogy for this is water. Think about it. At the micro level, you just have a bunch of individual H2O molecules. Is one single H2O molecule wet? No, of course not. That doesn't even make sense. But when you get a whole bunch of them together, interacting as a system, a totally new property emerges at the macro level, liquidity. The water as a whole is wet. So the wetness is caused by the behavior of all those tiny molecules. And at the same time, it's just a feature of the whole glass of water.
And this is exactly what Searle says is happening with consciousness. A single neuron isn't conscious. It's just a cell. But when you have billions of them firing together in this incredibly complex system we call the brain, this macro property emerges. And that property is consciousness. It's just a higher-level biological feature of the brain, just like liquidity is a feature of water.
Okay, so let's get to the big takeaway here. If you follow this line of thinking, you end up with a really powerful conclusion. We aren't machines. And there's a good reason why your specific biology is absolutely essential for your mind to exist. The argument really breaks down into 4 simple steps. Step 1, brains cause minds. We're pretty sure about that. Step 2, syntax is not sufficient for semantics. We learned that from the Chinese room. Step 3, computer programs are, by their very nature, defined purely by their syntax. And step 4, our minds? Well, they are full of semantics. They're all about meaning. So when you put those 4 things together, there's really only one conclusion you can draw. It's inescapable. No computer program by itself is ever going to be enough to give a system a mind. The whole idea that you can just write a clever enough piece of code and poof, create consciousness? Searle would say that's just fundamentally doomed from the start.
And this really gets at a crucial distinction, something we often forget when we see how amazing computers are. And that's the difference between simulation and duplication. Think about it like this. You can have a supercomputer run a perfect simulation of a thunderstorm. It can model every wind current, every pressure drop. But is your computer room going to get wet? No way, because you're simulating a storm, you're not duplicating one. It's the exact same thing with the mind. A computer can get amazingly good at simulating thought, but it's not actually thinking. That's the key. Simulation is not duplication. So in the end, Searle brings us right back down to earth, right back to biology. He's saying that mental states aren't some mysterious ghost floating around in our heads, and they're not a piece of software either. They're just biological phenomena. The mind is a part of our biological life history, just like growth, digestion, or breathing. It's a natural process. And that leaves us with a really fascinating question to ponder. If consciousness really is a biological feature, what other incredible mysteries are just waiting to be discovered inside our own brains? You know, we spend so much time looking at computers and AI for the next big thing, but maybe, just maybe, the greatest frontier of discovery isn't out there in the circuits, but right here, inside us.